Hello students, welcome back to the second video of this playlist. So in this video we will be solving the second question, that is question number 2 from May 2024 Statistics 1 that is S1 paper. So let's see what's the question number 2 is about. So the question number 2, the concepts behind question number 2, it has been discussed in discrete random variables chapter, that is chapter number 6 of your S1 textbook. So in order to be able to solve this question, definitely you should have practiced questions from chapter number 6 of your S1 textbook. So let's get started with question number 2. So here they are saying a spinner can land on the numbers 2, 4, 5, 7 or 8 only. Okay, the random variable x represents the number that this spinner lands on when it is spun once. So x represents the number on which the spinner lands. Okay, the probability distribution of x is given in the table below. We can see the probability distribution of x. Okay, so the first part, in part A, they are asking to find probability of twice of x minus 3 greater than 5. So we need to find out that probability. So let's see, for part A they are asking to find probability of what? X, twice of x minus 3. So we can write twice of x, take minus 3 to the right side, like solving an inequality, greater than 8. So probability of x greater than what? 4. So what would be that? Now let's see what are the possible outcomes greater than 4. That is 5, 7 and 8, right? So that would be what? 0.2 plus 0.1 plus 0.15. okay, so 0.2 plus what? 0.1 plus 0.15. So what's that? 0.45. Yeah, so 0.45 is the probability of twice x minus 3 greater than 5. Done. Okay, next, what they have asked in part B, given that expectation of x equals to 4.6, the expectation of x is given. We need to show that the variance of x is 4.14. So basically, I think if you have done chapter number 6, then you were supposed to know the formula for variance, right? So variance is basically what? Variance of x is what? Expectation of x squared, right, minus what? The expectation of x whole squared. This is the formula for variance of what? X. So expectation of x is given, we need to find out the expectation of x squared, right? So expectation of x squared is what? Summation of what? If I write expectation of x squared, this is basically summation of what? X times probability of what? X. Okay, sorry, x squared times, yeah, x squared. Since it is expectation of x squared, this is what? Summation of x squared times probability of x. That means x, each of the x values will get squared and multiplied by their respective probability. Okay, so let's do that. Expectation of x squared, we need the expectation of x squared. So for part B, we need the expectation of x squared. That would be what? The first term is 2, so 4 times 0.25. So 4 times 0.25 and then plus what? 16 times 0.3. 16 times 0.3, 4 squared is 16, and then 5 square is what? 25 times 0.2. 25 times 0.2. 25 times 0.2 and then what, 7 squared is what, 49. 49 times 0.1, 49 times 0.1, and at last this is what, at last this is 64 times 0.15, right? 64 times 0.15. So what would be the value for expectation of x squared? The expectation of x squared is what, 4 times 0.25, this is 1, plus 16 times 0.3 plus 25 times 0.2 plus 49 times 0.1 plus 64 times 0.15. So what you will get here is that 253 over 10. This is 253 over what, 10, which is 25.3 basically. So 25.3, we got the expectation of x squared. Now it's the time to find out the variance of x. So variance of x is what, expectation of x squared, that is 25.3 minus what, the expectation of x whole squared, right? So expectation of x is given as 4.6, so that would be 4.6 whole squared. Okay, so 4.6 squared, so what would be the value? This is basically 4.14. So the variance is how much? 4.14. Done. So we got the variance 4.14 as per asked by the question. Done. 4.14 is the variance asked by the question. Done. Okay, next, for part B, the random variable y equals to ax minus b, where a and b are positive constants, given that expectation of y equals to 13.4 and variance of y is 66.24. So we need to find out, in part C, we need to find out the value of a and the value of b. Okay, so expectation of y is given as 13.4. okay, so y is again ax minus b. So since y equals to ax minus b, what we can write? Look, expectation of y can be written as what? Expectation of ax minus b. Yeah, expectation of ax minus b. So what we can write here, this is a times expectation of x minus what? B, right? Okay, so expectation of x is what? It's 4.6. So 4.6a minus b, right? So what we can equate, they have given the expectation of y. So 4.6a minus b, this is equals to how much? This is basically what? 13.4. This is 13.4. This is the first equation. Now second is what? Variance. So variance of y. So variance of y can be written as what? Ax minus b, right? So ax minus b can be written as what? Okay, variance of ax minus b, it's given as 66.24. okay, this is 66.24. okay, now variance of ax minus b, we know that for subtraction or addition, variance doesn't get changed, right? So only for multiplication the variance gets changed by the square of the multiple. So that means a squared times what? Variance of x. Basically y you can say y is basically a coded data for x. Y is basically a coded data of x. Okay, so for coding, basically if you multiply the data values by a constant, due to the multiple the variance gets changed. The variance gets changed by the square of the multiple. Okay, so this is equals to 66.24. Okay, so we got the value for a. We can get the value for a here. So a square equals to what? 66.24 over 4.14, right? That's the variance of x. So what would be the value? 66.24 divide 4.14. So this is basically 66.24 divide 4.14. That would give you 16. That means the value of a is plus minus 4, right? So is it minus 4 or plus 4? Did they mention anything here about the value of a? A and b are positive constants. That means a is what? A must be 4. Okay, now what would be the value for b? B would be what? B would be 4.6 times 4. 4.6 times 4 minus what? If you take b to the right side, just substitute the value of a into the equation. So 4.6 times 4 minus 13.4, that would give you 5. The value of b is 5. That's it. Done. Next, the part D. In part D, let's see what they have said. In a game, Sam and Alex each spin the spinner once, landing on x1 and x2 respectively. So the Sam's score is given by s equals to x1, and Alex's score is given by what? R equals to twice of x2 minus 3. The person with the highest score wins the game. If the score are the same, then it is a draw. Find the probability that Sam wins the game. Okay, we need to find out the probability that Sam wins the game. Okay, in order to Sam win the game, x1, the score of Sam should be greater than the score of what? Alex, right? Okay, so let's consider the cases. If Sam's score is 2, if Sam's score is 2, if x1 equals to 2, then what should be the Alex's score in order to Sam win the game? That would be what? If you consider if x2 is also 2, if x2 is also 2, then what would be the score for Alex? That is, R would be how much? R would be 2 times, that is 4, that is 1. That means Alex score is what? Greater than what? Sam's score is greater than Alex, so Sam will win. So this is acceptable, right? Next, consider if Sam scores 4. Okay, if Sam scores 4, if Sam scores 4, and what should be the Alex's score? Okay, wait, x2, if you consider x2 that is 2, you are getting r equals to 1. If you consider x2 to be 4, then 4 times 2, that is 8. I'm considering the Alex score for x equals to 4. So 4 times 2, that is 8. 8 minus 3, that is 5. So it will get greater than 2. That's why let's ignore these values, like x2 equals to x2 equals to 4, 5, and so on. Okay, let's ignore these, because for these values of x, Sam will lost. Okay, Sam will lost the game. Okay, so let's consider what I said, x1 equals to 4. If Sam's score is 4, then what should be the Alex score to let Sam win? That means x can be 2 definitely, no issues there. If you consider x2 equals to 4, what would be the case? Let's consider the case. 4 times 2 is what? 8. 8 minus 3, that is 5. Still Alex is getting what? Greater. Sorry, yeah, Alex is getting greater. So 4 is not acceptable. Okay, so we got 2 combinations so far. x1 should be 2. Okay, x1 should be 2, x2 should be 2. Okay, second case, x1 should be 4, x2 should be 2. Next is consider x1 to be 5. If x1 is 5, consider x1 to be 5, and if x1 is 5, then definitely x2 equals to 2 is acceptable, because x2, if x2 is 2, then r is what? 1, which is less than 5, so definitely it is acceptable. But if you consider x2 to be 4, 4 times 2, that is 8, 8 minus 3, it becomes equal. Okay, it becomes a draw. Okay, so x2 equals to 4 is also not acceptable. We got another combination. x1 should be 5, x2 should be 2. That's what we need to do here. We need to separately find out the combinations. Then x1 should be 7. If x1 is 7, let's go up a bit. Consider x1 to be 7. Okay, if x1 is 7, consider x2 to be, definitely 2 is acceptable. Now 4 is also acceptable, because 4 times 2, that is 8, 8 minus 3, that is 5, 5 is less than 7. I'm considering 5 is what? If you put x2 equals to 4 into r, the LX score, you will get 5, that means which is less than 7. So still Sam wins. Now consider x2 to be what? 5. If x2 is 5, then 5 times 2, that is what? 10, 10 minus 3, that is 7. It becomes equal, so it will become draw. So ignore this value. So we got another combination, 2 combinations we got, 7, 2, okay, and 7, what? 4. Fine. Next, x1 is 7, and then the last one is what? Go up, x1 to be 8, and x2 to be what? Definitely 2 is acceptable now, definitely 4, and then 5 would be also acceptable, because 5 times 2, that is 10. If x2 is 5, put it into the equation of r. 5 times 2, that is 10, 10 minus 3, that is 7. Still what? Less than 8. So we got 3 combinations there, 8, 5, 8, 4, and 8, 2. Done. That's how that's how we need to find out the probability. Fine. So for part D, we need to find out that probability that what? Sam wins, right? Sam wins. So what's that probability would be? So let's consider the probabilities. At first, x1 was 2, right? x1 2 and x2 2, right? x1 2, x2 2. That means probability of x to be 2, this is 0.25, so there is 0.25 squared. Okay, this is 0.25 squared, this is 0.25 squared, then plus what? Plus, next is what? Next would be what? x1 should be 4, and x2 to be what? 2. So 4, 2, 4 and 2, that is 0.3 times 0.25, 0.3 times 0.25. Okay, that would be 0.4, 0.3 times 0.25. Okay, 0.3 times 0.25. Okay, so 0.3 times what? 0.4. Next, plus. Okay, next is x1 is 5, x2 is what? 2, right? That is 5 and 2. Okay, 5 and 2. What's the probability? 5 and 2. 5 is 0.2 and 0.25. So 0.2 times 0.25. 0.2 times 0.25. Fine. Next is what? Next is x1 is 5, x2 is 2, x1 is 7, x2 is 2. 2. Again, x1 is 7, x2 is what? 4. 2 possible combinations here. 72 and 74. 72, 74. So 0.2 times 0.1, and then 74. So 7 is 0.1 times 0.3. So 0.1 times 0.25, 0.1 times 0.25 at first, 0.1 times 0.25, and then this is for 7.2, and then again what, 7.4, which is 0.1 times 0.3, right? 7.2, 7.4, 7.2, 7.4, yeah, 0.3. Okay, so and at last we got for what, 3 possible combinations, right? When Sam's score is 8, 82, 84, 85, 82, 84, 85. Why not 7? So 7 times 2 is basically 14. 14 minus 3, this is 11. It's getting greater. Okay, so that's why we ignored 7. So 82, 84, 85. So 82 is 0.15. Okay, 0.15 times 0.25. 0.15 times 0.25. So 0.15. We can add them up, right? 0.15 times we took common 0.25 plus 0.3 plus what, 0.15 times 0.25 plus 0.3 plus 0.2, right? 25, 0.3 and 0.2. Okay, 0.2 next. 0.2. Now you just add them up to get the final answer. So let's add them up. So 0.25 squared plus 0.3 times 0.4 plus 0.2 times 0.25 plus 0.1 times 0.25, 0.2 times 0.25, 0.1 times 0.25, and then plus what, 0.1 times 0.3 plus 0.15 times what, 0.25 plus 0.3 plus 0.2, which is 0.75. So 0.15 times 0.75. That's it. So the total would be we got 0.4. We got 0.4. Okay, so this is the probability of Sam winning the game. Okay, let's have a check whether our probabilities were fine. So the first one was 0.2522, right? 0.25 whole squared, that's why 0.25 whole squared. Second one was x1 is 4 and x2 is 2. Okay, 4 and 2. 4 is 0.3 and 2 is 0.25. Okay, 0.3 times 0.25. 0.3 times 0.25, it should be 0.25. Okay, let's correct it out. 0.25. Okay, so if it is 0.25, so 0.4, we got 0.4 earlier. So from 0.4 we can subtract 0.3 times 0.4. Earlier it was 0.3 times 0.4, so it is 7/25, and then add with that 0.3 times 0.25, so you will get 0.355. it's not 0.4, it should be 0.355, and that's the answer. Fine. Okay, so that's all about the second question from May 2024 S1 paper. That's it.